Good day. Today is another tutorial. Today's tutorial I'm going to show you how to solve the quotient rule. How to solve the quotient rule. All right. Let's take a fraction like say s of x is equal to 2x squared and t of x is equal to x to the power 5. This one is a normal fraction. This one is a normal fraction. A very simple fraction. But we can still put this function together as a fraction of a fraction. So we say the whole thing st u. So let's say like w of x is equal to 2x squared over x to the power 5. See, this one you can't use the power rule to solve it. You can't use the chain rule to solve it. Or you can say a product rule, something like that. But you have to use the quotient rule because of the fraction here. The quotient means division, a fraction dividing another fraction. Alright. So quotient rule, we put it way like dw dx to be v du minus u dv all over v squared. Okay, so this is the general rule for quotient. Why are we saying v du minus u dv? It's a very simple way. Let's rewrite the question here. W is equal to 2a squared over x to the power 4. The reason why we are using v du is we classify the whole of the numerator to be v. Then we classify the whole of the denominator to be u. So we say dw over dx. This is a formula. We are rewriting it back here. Wherever you see v is the numerator. Wherever you see u is the denominator. And the du means you are differentiating. The v means you are differentiating. The v here means you are just maintaining it as a constant. Here is a constant. So we take v, and the v here is 2x squared. So we put 2x squared as a constant. Then we differentiate u, and the u is x to the power 5 over dx minus u, we put it as a constant, x to the power 5. Then we differentiate our v, and the v is 2x squared dx. Alright. This one is a constant, so we still write it back here, 2x squared. Then we differentiate x to the power 5. This one is a power rule, and if you don't remember, you go back to my tutorials on power rule and then go over it. So we differentiate x to the power 5. It gives us 5x to the power 4. Alright. Minus x to the power 5. When you differentiate 2x squared, it gives us 4x. From here we can simplify. We multiply through, so this time this gives us 10x. Then we add the powers, which is what? 6 minus, when you multiply this by this, it's minus 4x. Then we add the power. This one is to power 1, so 6. You can still subtract. When you subtract this from this, it gives us 6x to the power 6. That's it. Okay, so 6x exponent 6. This is not the final answer. 6x exponent 6 is the numerator for the formula. So we have to also find for v square. Alright. So v square is equal to the initial of v is this is v 2x squared. So 2x squared. 2x squared. And the question is, the formula says v squared, so we have to square it. As you see it here, it's v squared. And if v is 2x squared, then we still have to square it. 2x squared. Then this square is what is appearing here. Alright. And this one gives us, the whole thing is to the power 2. So we power this one, then we power this one. Let's do it separately. This gives us 2 multiplied by this. X squared multiplied by this. Alright. And this gives us 2 to the power 4 is 2 times 2 into bracket. X is to the power 2, and this times this is 2 times 2 here. 2 to give us 4, and x to the power 4. So we get 4x to the power 4. Okay, so v squared, which gives us 4x to the power 4. Let's go and fix it into the general rule. General rule says v du dw dx is equal to v du minus u dv, all respect to x, is equal to 6x exponent x over 4x exponent 4. So this is our final answer.